Hi, my name is Adel Sisy, and I'm presenting my Delta Protein Atlas for the 2025 Congressional App Challenge in Texas Congressional District 9. Diseases and health conditions are the greatest global burden on human life, with millions of lives lost and trillions of dollars spent each year. Furthermore, the research and development for a new drug is a decade-long process, costing billions of dollars, with about 90% of candidates failing after the Phase 1 trial. This underscores the need for a more predictive, human-relevant drug development strategy. The underlying causes of human genetic diseases is linked to 20 common amino acids in human proteins. To address these challenges at a large scale, I created Delta Protein Atlas web app, which precisely catalogs over 13,000 genetic diseases directly connected to over 38,000 unique proteins with all of their amino acid mutations, providing a novel disease-focused perspective on the exact causes of each disease. This atlas can help accelerate drug discovery utilizing nearly 300,000 pathogenic disease associations as targets, supported by 790,000 ClinVar submissions and 24,000 research papers. Let's deep dive into the atlas. Alzheimer's disease, which is the seventh largest cause of death in the world, is associated with 68 proteins and 333 amino acid mutations. And all of these mutations are cataloged in a table with their detailed information. Inside of the first associated protein sequence, we can see that it has 11 mutations, with each related to a distinct location in the protein structure. Each of the 38,000 proteins is also documented with their associated diseases and mutations. Let's look at amyloid beta, which is associated with 12 diseases and 290 amino acid mutations that are cataloged in a detailed table. Below the detailed table is the protein sequence and structure, which allows us to visualize the exact locations that are causing the 12 diseases. Delta Protein Atlas web apps code is made up of 4 main code files that are intricately interconnected to build the dynamic interface. The backend consists of server.py and script.js, and the front end consists of index.html and style.css. In server.py, the disease and protein drop-down items are created and dynamically stored. Then, a dynamic data response system is built when a given disease is selected or when a given protein is selected. Finally, the website is configured and bound to a local IP address. In script.js, the tab functionality and structure viewer are defined to make the website efficient while providing informative visuals. Then, the data response mechanism from the server and the structure viewer logic are combined to dynamically populate HTML elements when a disease or protein is selected. In index.html, the web app skeleton is built with detailed identification for each item. This allows the JavaScript and CSS to easily access specific parts of the web page for modification. The HTML is broken down into major blocks for each tab of the website. In style.css, the formatting of the website is curated to display all of the web app's information in an aesthetic and accessible manner. Finally, Delta Protein Atlas can have huge impacts in several fields. Thank you.